In this video we're gonna be solving some problems about derivatives. In the exercises we'll do, we're gonna have to calculate f prime if, and in the first example we're gonna start with an easy one. It's gonna be f of x equal to 3x to the power 3 plus 6x squared minus 2x plus 1. So you're gonna have to calculate f prime. So f prime is going to be the derivative of this function. And so what we're first going to use is that the derivative of f plus g, the derivative of the sum, is just the sum of the derivatives. So here we have sums and subtractions, so we can just separate it by the sum. 3x to the power 3, the derivative, plus 6x squared plus minus 2x plus the derivative of 1. And now we're gonna have to use two properties. Well, first of all, we have a few constants here that are multiplying to x to the power something. So 3, 6, and minus 2 are constants. And then we have the derivative of 1. So we're going to use two properties. First, that the derivative of c times f is c times the derivative of f. This is what we're going to do for 3, 6, and minus 2. And then for plus 1, we're going to use that the derivative of a constant is just 0. So then this is just 3 times the derivative of x to the power 3 plus 6 times the derivative of x squared minus 2 times the derivative of x, and instead of plus 1 we just plus 0 because of the second property. And now we will use something we have proven in our last video, and that is that the derivative of x to the power n is just n times x to the power n minus 1. So we're going to be using that in all these powers. 3, 2, and here is power 1. So we're going to have 3 times, we first lower the exponent, that is 3, times x to the 3 minus 1, plus 6 times, we lower the exponent, 2 times x to the 2 minus 1, minus 2 times 1 times x to the 1 minus 1, and that plus 0. So now we do all the calculations and we have 9x squared plus 12x minus 2, and that is f prime of x. That's what we were trying to calculate. And now we move on to the second example, the second problem. Now f of x is going to be a bit more complicated. It is x plus 2 times 3x plus 1 times 2 plus 5x squared. So we have the product of three functions, and we know Leibniz rules. That tells us that the derivative of two functions, the product of two functions, is the derivative of the first one times the second one plus the first one times the derivative of the second one. So here what we can do is just say, okay, I'm gonna call this function h and this product g. So then f prime in x is going to be, well, the derivative of this. And this, I said, it was going to be using this rule the derivative of h, so x plus 2 derivative, times the other two functions without differentiate, plus the first function, x plus 2, times the derivative of the second one, so times all this derivative. So here we have, well, x plus 2, we already know how to differentiate, but here again we have a product of two functions. So again, let's call it h of x and g of x and do the exact same thing. What we're gonna have is x plus 2, the derivative, times this whole thing, and then we're gonna have plus x plus 2 times, and again we use this rule, the derivative of the first one is 3x plus 1 derivative times the second one without derivative, 2 plus 5x squared. Now plus, and because we use the distributive law here, like this, and then we have again x plus 2 times the first one without differentiate, 3x plus 1 times the second function with the derivative, so 2 plus 5x squared derivative. And now we just calculate those. Okay, we know how to calculate the derivative of x plus 2 is just 1, and that's going to be multiplied by this thing. And then we have plus x plus 2 times the derivative of 3x plus 1 is the constant 3 times this other function, 2 plus 5x squared, plus, and again we have these two functions, and again we know how to differentiate this. We have a power here and a 5, so this is going to be 5 times 2x to the 2 minus 1, and that is just 10x. So now we just rearrange everything, and we get that f prime of x is going to be 3x plus 1 times 2 plus 5x squared plus 3x plus 2 times 2 plus 5x squared plus 10x x plus 2 3x plus 1, and that is just our derivative. It's a bit long and we don't really know what it is, but it's just a function. For the third problem, f of x is going to be 4x minus 3 divided by 2x plus 4. So the first thing we ask ourselves when we see a function of this type is, where is our function defined? Well, in the two cases before, we had polynomials, and polynomials are defined everywhere. So in these two cases we had no problems. But we do now, because here we have this number here. So what we have to ask is for 2x plus 4 to be different to 0. And this will happen if and only if x is different from minus 2. So f of x will be defined everywhere except in minus 2. So in particular, it won't be differentiable at x equals to minus 2. Okay, so we have the division of two polynomials, two functions. So here we're gonna use the rule for the quotient. The derivative of f divided by g is equal to the derivative of f times g minus f times the derivative of g divided by g squared. And that is whenever g of x is different to 0, and that is why we did this. Because in this case, 2x plus 4 would be our g, and 4x minus 3 would be our f. So let's use this rule and just calculate f prime. We have the derivative of f. F we said 4x minus 3 times g, that is times 2x plus 4 minus f times the derivative of g, and all this divided by 2x plus 4 squared. So that was very easy. Now we only have to calculate this derivative and this one. These are just polynomials, so again we know how to calculate them. We have here the derivative is just constant multiplying x, and the same here. So we have 4 times 2x plus 4 minus 4x minus 3 times 2. And all this divided by 2x plus 4 squared. And again, we have that the domain for f prime, it will be whenever the denominator is not 0. So it's going to be all the x in the real numbers such that 2x plus 4 squared is different to 0. This is different to 0 whenever 2x plus 4 is different to 0. And this is whenever x is different to minus 2. So f is differentiable everywhere except when x is equal to minus 2. So now let's move on and work a bit on the chain rule. Our fourth problem will be to calculate the derivative of f defined as the square root of 2x squared plus 3. We saw the chain rule. It was the derivative of the composition is f prime composed with g times g prime. And this rule might seem a little complicated, but it's actually not. So f prime of x is going to be the derivative of this. And here we can just separate this as two functions. On one side we have the square root, and on the other side we have 2x squared plus 3. So the way we do this is the composition of the square root with this polynomial. So f would be the square root and g would be our polynomial. So when we differentiate this, we have to get the derivative of the square root of x, evaluate it. I'm using this notation to not have two parentheses that might be confusing, in x equal to g, and g is 2x squared plus 3. This is exactly what this composition here is telling us. Calculate the derivative and then evaluate it in g of x. And then we just multiply by g prime. G prime is the derivative of 2x squared plus 3. So what is the derivative of the square root? Well, we have done this in a previous video. or you can just write the square root of x as x to the 1/2. So then just use the same rule as x to the n. This is 1/2 x to the 1/2 minus 1. So this gives us 1 over 2 times the square root of x, but we will first evaluate it here. 2x squared plus 3. And now just multiply by the derivative of this. The derivative of this is we have 2 as an exponent and 2 as a constant, so we get 2 times 2 x to the 2 minus 1. So then this gives us the function 4, 2 times 2, x divided by 2 times the square root of 2x squared plus 3. And we can just simplify this, and we get 2x over the square root of 2x squared plus 3. Now for the fifth problem, we're going to use a combination of all the things we learned so far. Now our function is going to be x plus 3 squared times 4x minus 1 divided by 2x plus 1 squared times 3x minus 2. So let's think about what f prime in x will be. So first of all, it's a quotient, so we can have the derivative of the numerator times the denominator minus the numerator without differentiate times the derivative of the denominator. And all this will be divided the denominator squared. So first we're going to be working on this top section. So let me just write what it is. And we start with this derivative. This is going to be a product, so we're going to have the derivative of x plus 3 squared times the second term without differentiate plus the first term times the second term with the derivative times these other two functions that are just multiplying the whole thing. And now we have all this minus, I'm just gonna continue here. We have this as a constant times this derivative, that's also a product, so it's going to be the derivative of the first one times the second one plus the first one times the derivative of the second one. Now we're going to be working on these derivatives. So first, let's think about this one. We have the derivative of something squared. It's a composition of functions. So we first differentiate this squared. It's going to be 2 times something, and that something is going to be whatever it is we have inside. In this case is x plus 3 to the power 2 minus 1, which is just 1. And this will be times the derivative of what we have inside. That is the derivative of x plus 3, which is equal to 1. So we have this multiplied by 4x minus 1 plus x plus 3 squared times the derivative of 4x minus 1. We have 4 times x, so this derivative is just 4. And we have the other two terms. Minus these two terms that are multiplying here. Again, here we have something squared, and that something is 2x plus 1. So we start by differentiating the squared. We have 2 times something, that is 2x plus 1, times the derivative of this is 2. And this is multiplied by 3x minus 2, and then we have 2x plus 1 squared times the derivative of this. We have 3 times x, so the derivative is 3. So now we can just put all these things together. So we had that f of x was this thing right here. And now we have done all the calculations for the numerator, and we have that f of x is equal to this big thing all this divided by the square root of 2x plus 1 squared times 3x minus 2. And now for the last example, we're gonna solve sort of a different problem. It's more of a trigonometry one, but it's not actually very hard. We're gonna solve the derivative of f of x when it's equal to e to the sine of x plus e to the tangent of x. So a few things to notice. The derivative of the tangent is the secant squared of x, that is 1 over cosine squared of x. The derivative of the sine of x is the cosine, and the derivative for the e to the x is just e to the x. So f prime on x is going to be the derivative of, and here we have a composition of functions. We have e to the sine of x plus e to the tangent of x. So how do we differentiate this? Well, we use the chain rule again. So for the first term, we're gonna have the derivative of e. We said it was e to the x, it doesn't change. So it's gonna be e to the sine of x times the derivative of sine, that is cosine, plus e to the tangent is going to be e to the tangent, because the derivative of e doesn't change, times the derivative of tangent, which is the second square root of x. Now let's do a geometric interpretation of what the derivative means. If we have the function f of x equal to e to the sine of x, then we know with all the calculations we just did that f prime of x is e to the sine of x times the cosine of x. So let's look at these two functions for a minute. Here we have this green function, it's the sine of x. And we can plot the derivative. And we see that the function and the derivative don't seem to have much in common. So let me just say this is f of x equal to e to the sine of x, and this blue one is f prime in x, which is e to the sine of x times the cosine of x. So we don't really see the difference between these functions. But let's do this. Let's just take a point, this one, and draw the tangent line from this point. It's going to be something like this. So when we draw it, we get this red line is the tangent to the function through the point A. And we said that the derivative, that f prime in x, was going to be the limit when h tends to 0 of f of, in a point x is x plus h minus f of x divided by h. So we are calculating for each point the second line, and when we get closer to x, we get this red line. Let me just delete these lines because they're awful. But this has something to do, this red line has something to do with the derivative. Well, the derivative here in this point, it's this number right here. It's minus 1.457 something, okay? 45 something. So what does this number have to do with this red line? Well, we can try and say, okay, plot a linear function with slope equal to g in 2.5 with this slope minus 1.45, etc. So when we plot this, well, this linear function is through the origin, right? Because it doesn't have any independent. For this line, in order to be equal to the red line, we have to add this number, 5 point something. But we don't care about that right now. All we want to do is visualize that the slope for the tangent line is minus 1.45 blah blah blah. So the derivative, it's telling us for every point what the slope for the tangent line is. But there's a bit more information we can get from it. Well, if we see here, we have that our tangent line is equal to 0. Here, all these points, our derivative, our blue function, is equal to 0. Well, what happens? It's telling us the slope in these points for our function. So in these points, we know that the tangent line is horizontal. But it's also telling us a bit more. When our derivative is decreasing, it means that our function well, in this case it's increasing, but it's increasing less and less every time, up to the point where it stops increasing, and that's why the derivative is 0, and then the function starts decreasing. So our derivative, it's negative in this interval. That's exactly when our function is decreasing. And it's positive, for example, in this interval, when our function is increasing. And that will happen every time. Here it's positive and our function is increasing. Here it's negative and our function is decreasing. And that is something that it's a theorem, it has a name, and we'll see in the next video. So let's try and visualize this definition, because we just said that the derivative has something to do with this tangent line. So to visualize this, we're going to have a look at another animation. In this animation, we are grabbing here a point in our function, the black function, and we draw the tangent line. It's this red line. So just let me clear things a bit. We have a function, we have this green point, and the tangent line. So what we do is we take an edge and we draw for another point, we draw the second line through this point and the one we first took. And now what we're going to do is make this point come closer to the first one. So that is, these points will be at a distance h, and we'll just make this distance bigger and smaller. So let's see what happens with the green line and the red one. We can see that when the point is close to the original one, the green line is similar to the derivative. So that is the definition of a derivative. That is why we're calculating that limit when h tends to 0. So now, as it's usual for us when we finish a practice video, we're gonna leave a few problems. The idea is for you to do the exact same thing we did in this video, is find f prime. We're gonna have 4 exercises. The first one, f of x, is going to be x squared plus 1 times the square root of x squared plus 1. Here we will have 2 ways of doing it. You can just calculate the product and then differentiate a polynomial, or use it as a product rule between the functions. The second one is f of x equal to the hyperbolic sine of x. This function is defined as e to the x minus e to the minus x divided by 2. So calculate this derivative. The third one is the hyperbolic cosine of x, and it's defined in a very similar manner. It's actually e to the x plus, instead of minus, e to the minus x divided by 2. And last but not least, f of x equal to the hyperbolic tangent of x, which is defined in the same way as the normal tangent, only that in terms of the hyperbolic sine and cosine, it's the hyperbolic sine of x divided by the hyperbolic cosine of x. So to calculate this derivative, you're going to have to do the quotient rule.